Chapter 4. Chapter 4 is about systems of linear equations and inequalities. I'm going to make like 3 videos for Chapter 4. This is video 1 for Chapter 4 review. I want to discuss very quickly that you need to understand how to solve systems of equations by the addition-elimination method, also by the substitution method, and by using Cramer's rule. So this first video is just to give you some background information on what this is all about, what it means to be a solution to a system of linear equations. If you have a coordinate plane, and you have the graph of 2 equations, and we want to talk about the solution to this system of equations, whatever those equations are, we would be talking about this point right there where the 2 lines cross each other, where they intersect, the coordinate, the x and the y value that is related to the point of intersection. That is the solution to a system of linear equations. That is a system of 2 equations in 2 variables. They would intersect at a single point. If you're talking about the solution to a system of 3 equations in 3 variables, yes, you're still talking about where the graph of the lines intersect each other. Except in that case, it's 3-dimensional. It's not just on a flat surface, but there is that 3rd dimension. So you've got an equation that has these 3 variables, 3 equations with 3 variables, and they intersect someplace in space, or they don't intersect at all. The other thing to remind you is that there's, in terms of a system of 2 equations, there are 3 distinct possibilities. One, where they intersect in a single point. A second would be where the 2 equations are parallel, that is, they have the same slope, and so they have no point of intersection. And a third possibility is, and I don't have anything here that'll help me do it, but would be where the 2 equations are not parallel, but they don't intersect because one equation is on this plane and the other is on a different plane. So there is no point of intersection. There isn't, and it's not parallel. So those are the 3 possibilities that you have when you speak of the solution to a linear equation. The next thing is to remember that there's a way that we can determine how many and what types of solutions there are for linear systems, and that is called the determinant. The determinant is how we can determine the number of types of solutions to a linear system. So when you set up a linear system of 2 equations, we want to figure out whether or not we have any solutions. We can do a matrix, and that matrix is called a 2 by 2 matrix based on 2 rows and 2 columns. And what we do is we take the coefficients of x and y and just bring them straight down, including the sign. So we end up with 2, -3, 4, and 3. And then the determinant is the difference between the cross products. So we're going to multiply here, and we're going to multiply here, and then we're going to determine the difference. So this product is 6. This product is negative 12. And what we're going to do is find the difference. So this becomes 6 minus negative 12, so with a result of 18. So there will be a solution to this system of linear equations. There's also a 3 by 3 determinant. And I will be brief. And that would be where you have, say, 3 equations. So that's a system of 3 equations in 3 variables, and we can find the determinant of it also. You simply bring down the coefficients, so now we have a 3 by 3 matrix, and there are 2 methods for determining the value of this matrix. One is where you extend the first 2 rows. You expand the first 2 rows. So that's called by expansion. And the second is where expansion by minors, which I will demonstrate when we get to using Cramer's rule. So if we expand, that is, bring these 2 columns over, repeat the 2 columns, we're going to look for the products down, and the products going up. And then we're going to add the products going down, add the products going up, and find the difference. So I will leave that up to you. That's the first review for Chapter 4. Are you awake?